Today we're going to learn how to write electron configurations, which is just stating where the electrons are, like arranged throughout the nucleus of an atom. Okay. So this slide, you don't need to write anything down yet. Okay. I just want to show you some examples, and then on the following slides, I'll teach you how to write them. However, when we write electron configurations, we write the shell number that we learned about on Monday, and then that number is followed by this subshell. And then we write the total number of electrons in that subshell as a superscript. Okay? And then we just keep on filling in those sublevels until we run out of electrons. Okay? So here's an example of helium. Find helium on the periodic table. Okay. How many, well, let me back up. What is the atomic number of helium? 2. So how many protons does helium have? 2. How many electrons does helium have? 2. So then helium's electron arrangement has to say, well, where are those 2 electrons? So helium's is 1s2. This 1 is referring to the shell number. The s is referring to the subshell, and then the superscript is talking about the 2 electrons. Okay, so helium's 2 electrons are in the first shell and the s subshell. Okay. Another example is sodium. What's sodium's atomic number? Okay, so how many electrons does sodium have?
2. 11.
Okay, 11. Okay, so sodium's electron configuration is 1s2, 2s2, 2p6, 3s1. Okay. So what that means is sodium has 2 electrons in the 1s shell and subshell. It has 2 electrons in the 2s shell and subshell. 6 electrons in the 2p shell and subshell, and then 1 electron in the 3s shell and subshell. Add up the superscripts. Add up the superscripts. What number do all of the superscripts add up to? 11. And how many electrons does sodium have? 11. Okay, so this is showing you where all 11 electrons are. In a little bit, I'm going to show you a video, and I'll show you like what this looks like. Okay. Okay, so get out your blank periodic table. Okay, so to learn the direction in which electrons fill around the nucleus, it follows this pattern. So we're going to color this. So you're basically going to copy this on one of your blank periodic tables. So the first 2 columns of the periodic table, we call them the S block. Okay, so on your periodic table, you need to color the first 2 columns, whatever color you choose. Okay. And then you also need to label the rows. So this row is the 1s row. This is 2s, 3s, 4s, 5s, 6s, and 7s. Okay. This middle section is the D block. Okay. Since this image was created, some elements have been discovered. So on your periodic table, you're going to shade in like this entire rectangle. Okay. And then make sure you label it 3D, 4D, 5D, and 6D. And then finally on the right side, we call this the P block. Okay. Same as the D block, your periodic table has this entire 7th row. So this will all be shaded the same color. And then you'll label these 2P, 3P, 4P, 5P, 6P, and 7P. And then finally the bottom 2 rows, we call this the F block, and it's 4F and 5F. So you need to basically copy this on your blank periodic table. So have the colors, make sure you label the rows. All right, so now we're going to talk about, well, how do we know which order electrons fill in? Like, how do I know what order I write electron configuration? So I want all of you to copy down, like, I call this a triangle. Copy this down in your notes. So this is the way we know how to fill in the electrons. So, and we're going to fill it in by column. Okay, so your first column goes 1, 2, 3, 4, 5, 6, 7. Okay. And then it's followed by the subshell. What is the first letter in the subshells? S. Okay. So all of these get the letter S after it. Okay. Then the second column, think number 2 for second column, only starts with the number 2, and it goes 2, 3, 4, 5, 6. What's the second letter for the subshells?
P.
P. So all of these get P's. Okay. All right. Then the third column starts with the number 3. Okay. And it goes 3, 4, 5, 6. What's the third letter for the subshells? D. So then all of those numbers get the letter D. And then finally, the fourth column starts with the number 4, and it just has 4 and 5. And what's the fourth letter for the subshells? Okay, F. So then those get the letter F. Okay, so now, if you can remember to make this triangle, you can draw these downward diagonal arrows, and then these tell you the order in which electrons fill. Okay, so electrons fill in the 1s first, then the 2s, then 2p, 3s, 3p, 4s, 3d to 4p, 5s to 4d to 5p to 6s to 4f to 5d to 6p to 7s, then to 5f to 4d. Okay, so that's one like memory aid, right? If you can just remember to write the triangle, you just follow the downward arrow. Okay, I'm going to change my slide, but the same diagram's on the next slide. Okay, so on this slide, this is the same filling order. Okay, another way you can learn to fill them in is you just read the periodic table like a book. So the first row is the 1s row. Okay, then you go 2s all the way to 2p, 3s to 3p, 4s to 3d to 4p, then 5s to 4d to 5p, and so on. Okay, so you pick either of those methods that you feel more comfortable with. So you can remember the periodic table by block, so S, P, D, and F. Okay, and you can just read it left to right, top to bottom like a book. Or you can remember this filling order. Okay, so now we're going to actually write some electron configurations. So I'm going to write them up here. Should you also be writing these down in your notes? Okay, so the first one's magnesium. So find magnesium on the periodic table. Okay, what's the atomic number? Okay, I'm just going to outline it on the periodic table here so we can see it. Okay, so then the way we figure out the electron configuration, we always start at hydrogen. Okay, and what did you call this row? 1s. Okay, and is it past both of the boxes that are 1s? Okay, so it has both of those electrons. So we're going to write 1s2. It's past both those boxes. Okay. Then after 1s, we go back to the second row. What did you call this row? 2s. And is it past both of those boxes? Okay, so we're going to write 2s2. Okay. Then after 2s, what did you call this row? 2p. And there's 1, 2, 3, 4, 5, 6. Did we pass all 6 of those boxes? Okay, so I'm going to write 2p6. And then finally, what did you call this row? 3s, and it's the 1, 2. Okay, second box. So then it becomes 3s2. So what this means is there's 2 electrons in that 1s, shell and subshell. 2 electrons in the 2s, shell and subshell. 6 in the 2p and 2 in the 3s. How many total electrons should magnesium have? 12. Add up the superscripts. What's 2 plus 2?
4.
Plus 6?
10.
10. Plus 2? 12. Okay, so this is how we keep track of all 12. I want to write down chlorine's configuration with you, and then we're going to pause notes for a second, and I'm going to show you a video of what this would look like. Okay. So one more. Chlorine. What's the atomic number for chlorine? Okay, 17. Do you see how I outlined it in blue? Okay, so same technique. You're always going to start here at hydrogen. What did we call this row? Okay, and are we past both of those? Okay, so it's 1s2. Okay. After 1s, where do you go? 2s, and it's past both of those. So 2s2. Where do you go after 2s? 2p, and it's past all 6. So we're going to write 2p6. Where do you go after 2p?
3s2.
Okay, 3s. Is it past both of those?
Yep. And then it's going to be 3p4.
Okay, after 3s, 3p, and then you just count your boxes. 1, 2, 3, 4, 5. All right, now go ahead and try all 3 of these on your own. So try to write the electron configuration for silicon, iron, and gallium. Let's check answers. So for silicon, what number is the atomic number? Okay, so 14. I'm just going to outline it. What did you write for silicon?
1s2.
Okay, 1s2.
Plus 2s2.
2s2.
And then
2p.
Okay, 2p6.
3s2. 3p2.
3s2. Why 3p2? Okay, so take a look at the periodic table up here. Some of you, I think, are still a little like shaky on how to do electron configurations. You're just going to basically read like the shells and subshells till you get to your element of interest. So we have 1s2, 2s2, 2p6, 3s2, 3p2. Okay. You ready to try iron? Okay. What do you get for iron? Do you really got it? Okay, what do you have?
You got 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and then 3d6.
Okay, 4s2, and then after 4s comes 3d, and how many over is it? Good. Do y'all agree? Okay, so this one is just after 4s. On your periodic table that you colored, did you label this one as 3d? So it just goes down a number, so it's 3d, and then you just count 1, 2, 3, 4, 5, 6. Give me a thumbs up if you got it. Okay. Give me a thumbs in the middle if you didn't, but like now that you see it, you got it. And a thumbs down is like, nope.
You got a jack.
Okay. Let's do galliums. What's the atomic number of gallium?
31.
Okay, 31. What do you have for gallium?
Go for it.
What's it going to start with?
1s2.
Okay, 1s2. Everyone do it with me. So 1s2, then what?
2s2.
2s2.
Okay, then what?
2p6.
Hold on, 2p6, then what?
3s2.
Okay, then what?
3p6.
Then what?
4s2.
Okay, then
3d10.
3d10. And then?
4p.
6.
1.
Okay, 4p1 because is gallium in the very first box of the 4p?
Yup.
Okay, so 4p1. Next, sometimes we can represent electron configurations with orbital diagrams. Okay. So on your page, copy down hydrogen here. Okay, copy hydrogen. And then if you finish hydrogen, also copy lithium. Okay. So orbital diagrams, they visually show you the electron configuration. Okay. So look at hydrogen on the periodic table. What would hydrogen's electron configuration be? What's hydrogen? 1s. 1. Okay, so hydrogen's configuration is just 1s1. So the way we write an orbital diagram is you list the shell and the subshell. Okay, so this is 1s. How many s orbitals are there? 1. So 1 box. Okay, so this 1 box represents the 1 orbital. And how many electrons does hydrogen have in the 1s? 1. Okay, so what does this arrow represent? The electron. Okay, so the purpose of the orbital diagram is it shows you if electrons are paired or unpaired. What's a pair? 2. So it's showing you if there's 2 electrons in an orbital or not. Is hydrogen paired or unpaired?
Unpaired.
Okay. If electrons are paired, they're stable. Do stable elements react? No. Okay. So hydrogen is unpaired, so does that mean it's going to react?
Yeah, it's reacting.
Yes. So like the strength of the orbital diagram is it shows you if electrons are paired or unpaired, and then it becomes really clear if they're going to be reactive or not. Okay. All right. Next we have lithium. What's the electron configuration of lithium?
1s2.
Okay. So 1s2, 2s1. So here we have the 1s. How many electrons are in the 1s? 2. What do you notice about the arrows? Okay, hold on, everyone look up here. What do you notice about the arrows?
One's up and down.
One's up, one's down. That's showing that electrons have to have different spins. Okay, so one goes clockwise, one goes counterclockwise. Okay. All right, you don't need to write aluminum down, but so here's aluminums. So it shows the 1s2, 2s2. How many p orbitals are there?
6.
Not electrons, orbitals. 3. So now do you see how there's 3 boxes? 3 boxes represent 3 orbitals. How many unpaired electrons does aluminum have?
Oh no, it has that one.
Okay, 1. So the purpose of the orbital diagram is to show if they're paired or unpaired. How many of you have noticed the pattern of 1s2, 2s2, 2p6? How many of you are already getting tired of writing 1s2, 2s2, 2p6? Okay, there is a shortcut. Again, you don't need to copy the notes down on the side, but pay attention though. You can use noble gases as a shortcut. If you look at the periodic table, what column have what column are the noble gases in? The far right. So like helium, neon, argon, krypton. You find the noble gas that's closest to the element. However, it has to come before the element. So its atomic number has to be lowered. You can put that noble gas in brackets, and that's replacing the electron configuration of the noble gas. So then you just write everything that comes after the noble gas. Okay, so for chlorine, neon is the noble gas that comes before chlorine. Okay, so you put neon in brackets, and then you just pick up after neon. So you have 3s2, 3p5. Okay, find calcium on the periodic table.
Okay, now what?
What noble gas comes before calcium? Okay, so you put argon in parentheses. So that replaces the 1s2, 2s2, 2p6, 3s2, 3p6. So then you just write everything that comes after argon. So what would you write?
4s2.
Good. Okay, let's do one more. What noble gas comes before bromine? Okay, bromine. Okay, krypton's right by it, but can you use krypton? No. So you've got to use argon. And then what would come after argon?
Yeah. Kryptonite.
Okay, then what?
Just make kryptonite.
Good. Okay.